Hello everyone, welcome to a new video. In this video I'm going to configure the OSPF in data center. In the last video you saw that we have some configuration, layer 2 configuration in these three switches, spanning tree, trunking, ether channel, and also at the end we just add a active standby between these two switches. In this video I'm going to configure the OSPF between these four devices, switch 4, switch 5, router 8 and router 9. Switch 4 and switch 5, they are layer 3 switches, and they will support the OSPF and will participate in the OSPF domain. But before starting, let me speak some about the OSPF. As you know, the OSPF is a link state protocol, and it stands for Open Shortest Path First. It means that it's a very efficient routing protocol for a large size of the network. And OSPF has some features, and these features make it very suitable to use for a large size network. Some of these features I can say that it's a link state protocol. It means it just sending the topology changes, and in compared to distant vector protocols like EIGRP, it doesn't send all the routing table. It's just sending the topology changes information to other routers. And also it has a hierarchical design. By dividing a network to different areas, we can decrease the number of routes and to use the memory of the routers very efficiently, and also to decrease the load on the routers. And then the other one, we can say it's very fast convergence. Any changes in the topology will propagate very fastly inside the topology to select a different path for a route if one router is down. And also it's supporting the VLSM, variable length subnet mask, to use the number of IP address very efficiently. Also supporting the authentication between the agencies. We can use a password for that. Let me see, I will use some I don't know, maybe the video become very long, but I will try to at least use authentication between one of these links to show you guys. And also the type of the routers, the network, the type of routers inside the OSPF domain will categorize to different type. For example, we have ASPR, DR, VDR, and like this, to actually to segment the network and to send the information to all topology. And also it's supporting some load balancing, and it use some cost. We can by selecting a cost between two different paths, we can easily engineering the routing path inside the OSPF. And in the next, I have to say that the OSPF using different type of LSS. Before that, let me speak about the DR and BDR. OSPF using the concept of DR and BDR in multi-access network. Multi-access network like Ethernet, for example, between these two ports. They are connected using the Ethernet, then it's using the concept of multi-access. In the multi-access, we can select one router as a DR and another router as a BDR. In this case, if any changes happen, this DR and BDR are responsible to send that topology change to other non-DR and BDR routers. And also In the non multi-access network, for example, in a serial link, this concept is not there, and it doesn't select any DR and VDR between the between the routers, and it's just sending the information directly. But now let me speak about the LSA. The actually the OSPF using different type of LSA to make the routing job done. For this, in this small topology that we have here, maybe I can show you two type of LSAs here, but the at all the OSPF using OSPF v2 have a 7 type of LSA, and once now it's 8 type because we have OSPF v3 for IPv6. But now just let me explain only 2 type of LSA, and the third type maybe in the future when I connect the DNVPN to this network and add that in another area, then we can maybe see the third and the fourth type of LSA also. But in this case, we only have 2 type of LSA. The first one is the router LSA. The router LSA is the LSA that's sent by routers to send the information of the directly connected interfaces. And the second one is the network LSA, and this network LSA is generated by DR because it's a multi-access network, and it's because it's a multi-access network, and it shows the DR and BDR routers. Okay, I think there is a lot of details about the OSPF. Maybe you can find this information also in the different websites, and maybe the we are using the Cisco switches in the Cisco website documentation. You can find all this information. But now let's start our configuration for OSPF. For this one, actually, as we are connected to through the Ethernet port, then our network will be the multi-access. For the multi-access, as I said before, the routers need to select the DR and VDR routers, and this selection is done by the actually which router should be DR and which one should be VDR. In this case, by default, if we don't apply any priority in the OSPF, by the router, when we open a process, we can say create a process of OSPF inside the router, it's going to use the loopback interface as a router ID. If the loopback is available inside the router, it use that loopback, because it's not going to become down, because it's not a physical interface to be disconnected or turned off. It's always up, and because of that, you just select that loopback as a router ID, and the higher IP address will be selected as a DR. In this case, we have a loopback in all these 3 devices. But one thing I can say, we can actually engineering this DR and VDR by setting the priority. But there is a but here. This selection of DR and VDR is not primitive. It means when one router the process starts sooner, it will be selecting himself as a DR, and even if we make the priority of other router higher than this one, still that router will be DR, because it's not primitive. It's not going to make the election again between DR and VDR and non-DR VDR routers. Okay, I think it's enough about the theory. Let's start the actual configuration here. I'm going to start from switch 4. For configuring the OSPF, we just need to type the command IP router OSPF. We need to have a process ID, and we can you can see this process ID between 1 and 65,000 something. I'm going to use process number 1, and make sure that when you select process number, this process number should be unique in all the routers inside that domain, and this router will not be converged as a OSPF. Now by default it will select loopback 0 as a router ID. We can verify it here. Show IP OSPF database. You can see that with the router IP of 10.10.10.104, the loopback 0 of switch 4, it's selected as the router ID. But we can also hardcode that. Router OSPF 1 router ID. I recommended to hardcode this because it may be different loopbacks and inside the switch, and it will select one of them. We can hardcode that to make sure that this loopback will help us to troubleshooting if we try to troubleshoot and see the neighbor of the OSPF process. In this case, we can easily recognize the router and the neighbors using this loopback ID. The loopback ID. 10.10.10.104. Okay, now I'm going to enable the OSPF process inside the interfaces. We have interface VLAN 10, IP OSPF 1 area. All the we have to select these areas 0 because according to the OSPF rule, all other areas should be connected to area 0, and all of them should be connected. Else we have some tunneling also between if our network is far away and it's not available to access, it's not possible to access area 0, then we can tunnel our area 0 to another area. We can tunnel to area 0 from another area, and actually it may be very rare. I'm not going to show you in this video, but maybe in the future if you guys need it, I can configure that also. But now I'm just going to configure the area 0 here, and interface VLAN 20, IP OSPF 1 area 0. Then we have interface VLAN 8, IP OSPF 1 area 0. We can select this interfaces as a range, but I just select them one by one to show you guys. Okay, in switch 4 we finish. Let's see if this interface is up. Do show IP interface brief. No, VLAN 8 is down, and also this is also down. I believe this VLAN is not created yet. Again, let me explain why. Because the VLAN is going to be created inside the VLAN database, and this switch is not a physical switch, it's a virtual switch, and it doesn't have any memory. It doesn't save the VLAN database. Every time we restart our switch, we need to make these VLANs again. If you guys try to troubleshoot and you see that this VLAN is gone, it's because this VLAN is not going to be saved inside the run and config. Actually, we need to create that VLANs every time that when we restart our switch. Let's create VLAN 10, VLAN 20, and VLAN 30, and VLAN 8. Okay, now VLAN is created. Let's go to interface VLAN 8 and no shutdown. Do show IP interface brief. Now VLAN is become up. VLAN 8 is up, and this VLAN should be up soon. Let's go to VLAN switch 5. In the meantime, let's bring this out and see when the VLAN is turned on. Conf T do show IP interface brief. Same here, and they are all down. But this switch is we configure that as a VTP server, and it should propagate all this information to this switch. And let's check. Let's configure that again. I believe it may be also deleted. VTP mode server and VTP domain Cisco. Okay, it's from null to Cisco. It's also, it means that the VLAN is not created, the VTP is not configured here. And let's write this information from here. Conf T VTP mode and client and VTP domain Cisco. Do show IP interface brief. Only VLAN 20 is down and VLAN 20 is also up now. It means that the VLAN is created. Do show VLAN. Yes, the VLAN is created here and the interface is up. Let's configure our OSPF router. OSPF 1. As I said, we have to select process ID 1 because we choose the one here in switch 4. Now it should be one here also. Router ID 10 10 10 105 for switch 5, and let's go to the interfaces. Interface VLAN 10, IP OSPF 1 area 0, and interface VLAN 20. You see that the agency is up very fast, and IP OSPF 1 area 0. Now interface VLAN, we have one VLAN here, VLAN 9, the communication between the router 9 and switch 5. Yes, this one is also up, and VLAN 9, IP OSPF 1 area 0. Okay, now we just configure this to switch. Conf T Conf T. Okay, before configure this, let me see here. Yes, you can see the router link states means this. They are the type 1 LSA, and this is the router ID of this links actually, and this is the net link states. It means that this is the type 2 LSA. Type 2 LSA means the LSA is showing the link ID and the router ID actually. To see about DR and VDR, let's show IP OSPF neighbor. You see, because the switch 4, we configure the switch 4 first, then it select himself as a DR, then the neighbor ID 105 with VLAN 10 and VLAN 20, it's selected as a BDR. Maybe in the future, in this configuration, we just change this DR and VDR. Let me see if I can, because as I said, every router come sooner, it will become DR, and the next one will become VDR. It's not any preemption. Maybe we will not be able to select it as a DR and VDR. Okay, this is, let's configure that in switch 8 also. In switch 8, We have a problem here, duplicate ID on 02. 02 is here. Let's see, to show IP interface, show run interface is 02. It's 21. Maybe the next side is same IP address. Show run interface is 02. Yes, let's fix this. IP address, it should be 22. Okay, now problem is solved. Let's come back. Router OSPF1, router ID, and 10, 10, 10, 8, and interface is 01, IP OSPF1 area 0, and interface is 02, IP OSPF1 area 0. Okay, do show IP interface brief. This interfaces 01 and 0 are up. Okay, let's do it in router 9 also. Router OSPF1, router ID 10, 10, 10, 9, and interface range 0, 1 to 2, IP OSPF 1 area 0. Okay, now we have configuration in all these three is 4 devices, switch 4 and switch 5. This agencies never come up. Let's see, do show IP interface brief. Interface is up, it will take some time. Do show run interface A0, 1 and 2. Do show IP OSPF neighbor. Yeah. We have neighbor agency between router 8 and router 9, but not with switches. Let's see. Do show IP interface brief. We have interface VLAN 9 is up. Do show run interface VLAN 9. We have the OSPF process here, and do show IP OSPF neighbor. We only have 2 neighbor. Switch 5 and router 9 are not going to be neighbor. Let's troubleshoot that, see what's the problem. Let's check if this port is in VLAN 9. You show run interface A0, 0. Yes, it is, and it's up. Let's see, do show IP interface brief. This port 01 is up. IP 18. Do show run interface VLAN 9. 5, 85. Okay. Do ping, let's ping. This is the connect interface. 18. Cannot ping the 18. Why? 01 is here, and do show IP interface brief. This is VLAN 9 is up. Do show VLAN. Okay, we don't have VLAN 9 actually here. It's not created. But why? Show VLAN. Okay, VLAN 9 is not created in switch 4. If we try to create that here, it will not work because it's a client. VLAN 9. You see that BTP is not allowed to create in the client. conft VLAN 9. Okay, now do show VLAN. The VLAN should be automatically created here. Okay, it's created, and now we should see the agencies between switch 5 and R9. Now we should be able to ping between these two. Ping 17. Not yet. Okay. Now ping is succeed and the agency is up between these two. Now if we check show IP OSPF mirror, show IP OSPF mirror, we can see that we have two neighbors here in router 9 in this router, one with switch 5 and one is with router 8. Okay, let's see the LSA here. Show IP OSPF database. Okay, you see that we have the net link state. Net link states mean the type 2 LSA, the network LSA that will show up here, and because we are in the Ethernet and they are by default the OSPF network type inside the Ethernet is multi-access, and if I change that, I can change it. For example, I'm going to interface 02. Okay, before that let me show you. Do show run interface is 02. The IP address of this is 21. You can see in this link 21 and 22. 22 is in the other side. We have the net state, net link state in area 0 as a layer 2 type 2 LSA. Now if I change the network type between the R8 and R9, we'll see that this LSA will disappear. IP OSPF network point to point. Okay, with this point to point, you see the agency will start, and now you see the network type is mismatched because on the other side we have the OSPF, still we have the OSPF multi-access. Let's change that one also. Interface is 02 IP OSPF network point to point. Point to point means now this router thinks, I cannot say things. We just configure something to point to point. It means like a serial port. In serial port, the default OSPF network type is point to point. Now if we see show IP OSPF database, you see that the link ID before we had 21 here, 22 here. Now we don't have 22 was here. Now the 22 is disappeared because there is no any concept of DR and BDR between the point-to-point network in OSPF. Okay, we can actually configure all of this to just remove this type 2 LSA, but this type LSA it's just show the directly connected link, and we cannot change that. Okay, now our OSPF is configured. Let me see what else I can show you here. Okay, let's see the route here. Actually, show IP route OSPF. You see this O means the OSPF, and this is the route that we have here. This is VLAN 20. This is VLAN 10. Actually, we are in. Make notice that we are in R9, but we have the route of VLAN 10 and VLAN 20 here, and we should be able to ping it. But now I don't have any devices connected in this. But also we can have the loopback to the OSPF domain to make sure to ping the connectivity between this. Okay, interface loopback 0 IP OSPF. IP OSPF 1 area 0 and switch 4 also interface group by 0 IP OSPF 1 area 0. Okay, now we should have route 10 also inside. Yes, we have route 10 here. 104 and 105 should come soon. Yes, the 105. Now we have this two route and we should be able to ping them. 104 and okay, we are able to ping 105 but not 104. Let's see what's the problem. Let's ping it from here. 10, 10, 10, 104 and 105. Okay guys, before when I try to ping 10, okay, let's ping 10, 10, 10, 105. We can see that we can directly ping to switch 5, but if I try to ping it from its router switch 4, it's not working. And let's try this one here. Ping 10, 10, 10, that 104. Oh, sorry, not here, it's switch 8. Ping 10, 10, 10, 104. We can see we can ping the switch 4 but not switch 5. And I just tried to troubleshoot this, and later I just remember that the virtual switch actually doesn't support the IPsec. And let's speak about the IPsec later. But if I just disable the CEF here, no IPsec in switch 5 and also no IPsec. In switch 4 we see that we will be able to ping these routes. And you know, the CEF, if I speak about that, is a technology that is introduced in the Cisco to make the fast transfer of the packet, and the CEF is going to just take the packet, encrypt that and send it. But it's not actually working in the virtual switches. Then we just disable the CEF, and now our ping is going normally. There is no problem. Let's add this two switches also, loopback interface of this two switch into OSPF. Interface loopback 0, IP OSPF 1 area 0, and also here T interface loopback 0, IP OSPF 1 area 0, and the right. Okay. Anyway, when a route passes through a switch, if we have our IPsec enabled in this virtual environment, it will not work. Now our configuration is finished. Let me see if anything else I can configure here for you. Okay, I remember I just promised to make authentication also, the show authentication between the OSPF. In this case, I'm going to make the authentication between R9 and R8 in the interface base. Actually, we can configure the authentication in area base also, but in area base, if we enable the authentication in area, that router will be completely disconnected from all the network, because it's going to authenticate to area 0. Because of that, I'm just going to configure only authentication between these two links. In this case, I need to go to interface E02, first command IP OSPF authentication, and then IP OSPF authentication key. I can give a key Cisco. Now you see that this two switch will be these two routers will be disconnected, not disconnected. The OSPF agency will be go down. Just a moment. Actually, we have two type of authentication in plain text and also message digest. We can use MD5 for that. You see that the agency will get down and the timer expire. Let's configure that here in this side, and we will see that the agency will come up again. Interface is 02 IP OSPF authentication. Let's first give the key and then IP OSPF authentication. Now this two router, if this key is same, this two router will be agency again. Yes, we'll see that this two routers will become neighbor again. Okay guys, thank you for watching. In the next video, as this video is become a little bit longer than I expected, I'm not going to configure the EIGRP here, but in the next video I'm going to configure the EIGRP. Also you will see, as I said, the EIGRP is a link state. The Cisco says the EIGRP is a distance vector, but Cisco says it's a link state protocol. It's not a link state protocol. It's a distance vector protocol, and it's sending the all routing table to other router. Actually, EIGRP is very good protocol because it's very simple and it's very suitable for a small size network. A small to medium sized network. Nowadays, we know that all routers are very powerful and it has a lot of memory. Then we will not face any problem with the EIGRP. EIGRP, I think, for a small and medium sized network, the EIGRP is very suitable because of the simplicity in the configuration and also some other feature that it has, like authentication, and also to send the routes. We can see the routes in our table. There is no concept of DR and BDR to selection like that. Oh, I speak about the DR and BDR before. I promised to show you the DR and BDR here. Let's see. Once again, I'm going to open switch 4. I just forget that. Show IP OSPF neighbor, and you see this switch is a DR because the switch 5 is BDR here, and also in router 8 it's BDR because the switch 4 it's configured first. If we want to change this, let's do something. Conf interface VLAN 10. I'm going to do it very fast. In VLAN 10, I'm going to give IP OSPF priority 255. It means that it should be DR, and interface VLAN 20. I'm going to give it IP OSPF priority. By default, the priority is 1, and I'm going to change that to 254. The priority is a value between 0 and 255. 255 is the higher value, means the better, and it will become the DR. But let's do this configuration also in switch 5. If you see the last video, I just make the VLAN 10 as active here and the VLAN 20 as a passive. I'm going to do same for OSPF. For VLAN 10 will be the DR in the switch, and for VLAN 20 will be the BDR. You see the VLAN 20 the priority is 254, but for VLAN 10 we are 255, and here is in the reverse. In VLAN 10 we are 254, and for VLAN 20 we are 255. Now if we check to show IP OSPF neighbor, we'll not see any changes because as I said, it's not preempt. For actually to see this, let's do something. Let's turn off VLAN 10, VLAN 20. If we turn off the VLAN 20 interface, VLAN 20, shut it down. Okay, after shutdown, the agency will go, and let's wait for other side also to update the routing and to update the new information. We'll show IP OSPF neighbor. Still it's here for VLAN 20. Let's wait. I'm going to stop the video because it's going to become very long. Okay, it's expired, and if we see, we don't have any connection between any neighbor between switch 4 and switch 5 in VLAN 20, and let's hit no shutdown, and let's make hope that the switch 5 become active. Okay, let's do something. Let's interface VLAN 20, shut it down here also, and now no shutdown, and also no shutdown here. Now if the link up and the agency create again, we may see that the switch 4 will be the BDR for VLAN 20. Show IP OSPF neighbor. It's rather, it means that it's still negotiating on selection. We'll soon see that it should be DR. Switch 5 should be DR. Not yet. Okay, it's become DR. You see that switch 5 become DR because it has a high priority in VLAN 20, and it's BDR in VLAN 10. And same if you check it here, show IP OSPF neighbor. Yes, you see that in VLAN 10 the switch 4 is DR, and for VLAN 20 the switch 4 is BDR. Okay, let's finish our video. Thank you for your watching, and please be with me to complete this configuration of this network. And in the next video we are going to configure the EIGRP in these three sites. They almost be same because they almost have same devices, and when I configure one, we will see, we'll learn everything, and I will fastly configure this too. Okay, thank you for your watching. Please subscribe my channel for more video, and please let me know if you have any question, and once again please let me know if I made any mistake in this configuration, and also in my script if I said something wrong, please let me know. I will be much than happy to learn from you guys. Thank you for your watching. See you in the next video.